Next speech will...
Of Umberto, I think that when regulation will become infeasible, research is needed for trying to solve such problem. Let me say that you are really focused on the next 5 years, 10 years regulation. We saw also the presentation of Lloyd's. I think that you should be worried more what is coming after 10 years. You have to know that actually the European Commission is negotiating with industries further requirements. For example, we are talking in 30 years to drop the CO2 to 80%, zero emission or on NOx and sulfurums, which is beyond the actual technology. Let me say that actually a new ship will arrive at these 30 years and has to face during this time an increasing requirement of improving and new regulation will come out from IMO. So I'm providing here just a view that it's completely different from the previous speakers. So my view is a research point of view. And it's just 10, 15 years before solutions come into the market. So I'm going to present exactly what happened on this project. That is a streamlined project. It's a European project regarding the improvement of propulsion systems. And this project is over. It's over almost 2 years ago. And is a project where we develop some, let me say, new devices to be used for retrofitting ships, comparing to the design capabilities of the actual, let me say, state-of-the-art technologies. So let me start from this diagram. I don't want to make a very technical presentation, but this figure is coming from IMO report 2009. For me, it's giving a lot of information for people that manage energy on board of a ship. So you could see that this table is the bunker energy going into the ship, 100%. Where is going the energy? This is a case for a cargo ship, so it's typical for shipping aspects. Of course, changing type of ship, this breakdown of energy will change. But for these ships, most of the energy for the bunkers, so the money that you spend for the ship, is going to the shaft. Then there's a breakdown to propulsion that is needed for hull friction. This is 60%, air resistance, and wave-making resistance, and again, weathers and waves. Some energy is lost in the propellers, but you could see here that where the future has to go for energy management on board of a ship. So we are losing 27% of energy in the exhaust, and we are dropping 30% in cooling. So if we can, actually we are working in this area. This is my work normally, is working on the propulsion. But if you gain half of this energy, and we are able to re-put inside the ships, this will give us big advantages. And this will be the futures, how to use the exhaust energy from the exhaust. And there are solutions that are also already available in the market. Actually, it's a problem that most of you has to face. My ship is a mid-life. What I can do to improve? This is a question that I think is important and to find an answer. So today, most of the energy is going to be recovered if you want to make, let me say, retrofitting of your ships. Of course, let me say that hull friction is a very large one. So we saw that before some solution about smoothing and surface treatment will be very effective because the fraction of energy that is lost there is very important. But on the other side, the propulsion system has to face an optimization because we can change a little bit at such losses. So what I'm going to talk to you is about recovering propeller from the energy or to change the inflow into the propeller trying to recover the energy. And there are two types of, let me say, devices available today on the market. Some of them is just going on the market. We saw before Becker Marine, but there are other solutions for Rolls-Royce, I suppose also from Wärtsilä, I think that are available some solutions. So recovering propeller from the energy from the propeller, there are some coaxial contra-rotating propeller, free rotating vane wheel, that propeller, post-wheel devices, All these names change depending on the providers, but more or less behind such names, there are always the same idea. Others are working on the flow of the propeller, so changing the wake of the ship, trying to improve the propellers, guide vane, precision device, wake, equalizing that towards generations. I think that today this is technology that is available on the market, but what I will try to show you that is very difficult for you to have a solution, this solution, let me say. You can find your solution, but will not be the solution usable for everybody. So results I'm going to present us from the Streamline project is a very large project of 11 million euros that has been founded in 7 framework, 22 partners around the world. It was coordinated by Rolls-Royce. And most of the research institutions were involved, from Marine, INSEAD, SSPA, HSVA. And so we split the work between all these institutions to trying to make three types of, let me say, of work. First, to explore new concepts that are the large area propeller, distributed propulsion, biometric propulsion. I think that you told me that there's a solution about a large area propeller. These are new concepts that requires a new concept of ship. And of course, we require, let me say, if you are looking to a new ship, this solution will be, let me say, state of the art. And of course, there is some risky if you will be the first one to get such solution. I think you have to be sure that you have some guarantees getting this solution. But of course, from research point of view, I'm trusting this one. The other one is to try to optimize the actual, let me say, state of the art propeller. For example, the discrete propulsion pods and water jet. All this work has been distributed among all the partners. So, of course, from your point of view, I think that's more interesting, this type of ship that was test case for shipping. The test case for the project was these 7,000 tons chemical tankers, it's small ships, it's 100 meters. But this is a typical ship that is representing most of short sea shipping. And you could see the speed of operation is 13, 14 knots. For the ship, it has been taken as test case to study different solutions to try to improve the propulsion system. And of course, here, let me say that the work has been done also from both sides, from the experimental point of view and from theoretical modeling point of view. Let me say that we talked before about greening, looking to the CO2 emission, but nobody said that there is another requirement that is going to come into changing, providing new regulation, is noise emission in water. Actually, in the next, I don't know, because I'm not expert in regulation, maybe Lloyds can give us numbers. The goal is to drop the noise, the acoustic emission in water 10 decibel, which is a number which is huge, it's immense from this point of view. And this will be more difficult to achieve than CO2 emission because it requires to have free cavitation propellers, which means completely new design for a ship. And when this regulation will arrive, I think that we'll approach this problem let me say, step by step. I don't think that will be a big step, but I think that should come to this point. So, looking to this test case, there were two parallel approaches. One was what we can achieve today. We start to design new ship with data requirement and what we can achieve. And of course, I will not give you any information. Let me say that if today we design a new ship with the available tools today, engineering tools, let me say, state of the art, of course, we can design a ship that is 8–9% more efficient than a ship of 10 years ago. But this, of course, is something that can be applied today for a new ship. But if you have a ship that is 10–15 years old, at midlife, you want to make some retrofitting, there are other solutions, and this is what I'm going to present to you very quickly. So there are many solutions. I mean, I think that I saw tens of that. So, but what I can tell you that in the project has been tested mainly this type of solution. You could see that very simple. You can apply such type of appendages, and this appendage can modify the inflow of the propellers. Changing the inflow of the propeller has a new working condition, and this can provide a less torque, a different revolution rate, requiring different powers. Of course, most of them are, let me say, very simple. This is a boundary layer alignment duct, vortex generator. This is press wheel or stator. This is an optimized rudder, and this is a twisted rudder. And of course, you could see that it's not a solution. No, I mean, depends on your designer, who is the technicians. And I think that it's important to understand that, for example, today there is a new technology for design propellers. This is, for example, is a propeller designed by my institution. We achieve a propeller with 4% better efficiency. So you can replace the blades of the actual ship, getting a new performance with the same diameters. I mean, we didn't change only the shape of the blades. Of course, the twisted rudder is quite difficult, more difficult to build, because I know that in construction, you don't like to have very complicated shape. But this one, we saw that will be very effective because it is working in the wake of the propeller, where we lost a lot of energy in rotational motion. And this motion is recovered by the shape of the rudder. And of course, this is a solution that can be easily applied also in the mid-life of the ship. This is a press wheel. It's more complicated, but it's working on the same principle. So before the propeller, we twist the speed. We put the flow in rotation. This is changing the inflow of the propeller and changing the efficiency in the propulsion point of the propeller. This is more difficult to apply because it requires the dismounting of the propeller. And of course, this one, it's the boundary layer alignment duct. This is very simple to adopt. At the end, this is a vortex generator. Let me say that actually this is a figure that I got from IMO. It's a table that maybe most of you maybe could have a look. And you see that I'm sorry, I don't know if you are able to see this, but you see that for the case that we analyzed, we get let me say potential reduction of fuel consumption of the order of 2% for optimized propellers. That's what we got also in the project. Press wheel device between 1 and 9%. Post wheel device 1 to 9%. Let me say that from a technical point of view, this is quite difficult to achieve because, for example, for the case of the tanker that we got as our test case, you could see the main effect of this device to change the inflow. This is the inflow of the propeller. This is changed dramatically. And most of this solution are increasing the powers. So it's not easy to say, most of us fail in trying to make an optimization using this device. Really the advantage was in the twisted rudder in press wheel rotors. So at the end, you could see this in this table. So there is a risk when you adopt such solution that you hope to gain, but you lose. You see, for example, vortex generators that are very simple. If you don't take care in design, you can have an increase of consumption, not a decrease. While for twisted rudder, I'm quite sure that today also press wheel stator that this is a real gain. But this is the numbers, 1%, 2%, is not 10%. I don't think that today is possible because this is energy that we recover from the propeller. There is not so much energy lost in the propeller. So let me say that if you adopt one of these configuration, vortex generators or boundary layer alignment duct, you have also to redesign the propeller. You cannot use the previous propeller. This is what was the outcome of our projects. And the other aspect that I could say that the most effective aspect of this generator are changing the noise of the propeller. So if you are looking to reduce the noise of your propulsion system, which is the main source of noise, you have to work on these devices looking to the reduction of acoustic emission. Thank you very much for your attention. I hope not to be very complicated presentation.
Thank you very much, Fabio. It's impressive to see all these solutions possible, but what is most impressive was your first slide in which from 100% of fuel, most so the 70% is thrown away. It means if you use 1 ton of fuel, 700 kilos are off.